Bismillahirrahmanirrahim. Welcome to the Rado Institute. For this time, we will discuss about the comparison 1, 2, and 3 parameter Sujatha distribution with the application to the new case COVID-19. Okay, in the Rado Institute, we have discussed about the 1, 2, and 3 parameter Sujatha distribution. You can join with the www.radoinstitute.com and you can come to the tools of the international research class. You can check the explanation about the three parameter Sujatha distribution. I hope the explanation can help you to support your research when you use this distribution to make the another model. Okay, for this time, we will make the comparison with the 1, 2, and 3 parameter Sujatha distribution to the new case COVID-19 in Indonesia. Okay, let me check our research article to support our program. Okay. In the one research article with the title on modeling of lifetime data using Radhana, Sujatha, Lindley, and exponential distribution. In this research article, there is an explanation about the Sujatha 1 parameters. Okay. According to the research article, Sujatha with 1 parameters is come from the theory of mixture distribution. There are 3 density functions, namely exponential theta. Exponential theta is equal to gamma 1 theta with the parameter set is 1 and the scale theta, and then gamma 2 theta, and then gamma 3 theta. With the first weighted theta power 2 divided theta power 2 plus theta plus 2, and the second weighted theta divided theta quadrat plus theta plus 2, and the third weighted 3 divided theta power 2 plus theta plus 2. If you use the theory about the mixture distribution with the 3 gamma distribution function and then 3 weighted, of course, give the density function for the 1 parameter of Sujatha distribution. Okay, in this research article, give the Ft equal to t theta power 3 divided theta power 2 plus theta plus 2 multiplied by 1 plus t power 2 and multiplied by exponent min theta t. This is the density of the Sujatha 1 parameter. So you can check here the well explanation about the Sujatha distribution with 1 parameter. And then from the another research article with the title 2 parameter Sujatha distribution that published in the Biometric and Biostatistic International Journal on the 2018, there's a well explanation how it comes from the Sujatha 2 parameters. Sujatha 2 parameters use the theory of mixture distribution. There are the 3 gamma density functions, generally gamma 1 theta or exponential theta, and the gamma 2 theta and the gamma 3 theta with the first weighted alpha multiple theta power 2 divide alpha power plus alpha multiple theta power 2 plus theta plus 2, and the second word theta divide the alpha multiple theta power 2 plus theta and plus 2. And of course, for the fifth vector, namely or equal to 2 divide alpha multiple theta power 2 plus theta plus 2. Because we know if the all vector, if we take the summation for the all vector must be equal to 1. So we automatically we know the sixth vector here or P3 equal to 2 divide the alpha multiple theta power 2 plus theta plus 2. And then use the theoretical about the mixture distribution, and you can find the two parameter distribution equal to theta power 3 divided alpha multiple by theta power 2 plus theta plus 2 multiple by alpha plus x power 2 and multiple by exponent min theta x. So this very nice explanation about the two parameters Sujatha distribution. And the last one, we have the theoretical about the three parameter Sujatha distribution with application published in the European Journal of Statistics and Probability in the 2020. We have discussed before about these three parameter Sujatha distribution with application. And it is not important to discuss again about this distribution because we have discussed about this distribution complete with the R programming. Okay. After we are discussed about the three research article, and then for the last one, we will discuss about the R programming to support our international research class. Okay, we stop share. We open our R programming. Okay, this is our R programming here. We have the some R programming to support the problem about the new case COVID-19. Okay, we have the data. The first one we edit clear console. Okay, this is our data. Our data is about the new case COVID-19 in Indonesia. Okay, after we have data, we can take our programming for Sujatha one parameter. We are use the programming maximum likelihood. Of course, we must need the theta iteration theta k equal to the initial theta. You must plus the log likelihood and then the second derivative for the density function, because the first derivative for the log likelihood and the second derivative is the we need for the use for the theoretical of the Newton fraction. Okay, this is what we use iterated. We use while. Okay, we use the while for the iterated this programming. There is no difficulties here, so very easy. You can check by yourself. It's very easy. This one is Sujatha one parameters. We use the initial value for the theta 0.01. After that, we take the parameter, and then is for the likelihood, and then this density function for the Sujatha one parameter. Theta power 3 divide theta power 2 theta plus the theta plus the 2 multiplied by 1 plus xe power 2 and multiplied by exponent minus theta xe. Don't forget, we use xi. Xi is mean the all value. The xi is been the sequence 0 to power maximum data with the step 0.1. We need the a lot of point for the xi because we need for the produce the smooth graph for the Sujatha one parameter. Okay, after Sujatha one parameter, we use the Sujatha 2p. Sujatha 2p it means the Sujatha two parameters. Sujatha two parameters. Of course, we need the matrix Jacobian. Matrix Jacobian comes from certain derivative from the log likelihood. So we have the metric S here. S is a metric for the, this is S for the metric, the log likelihood. We have the two parameters. Of course, the S matrix with the size one column, two metric, two row and one column. The first row for the derivative of the density function for the first parameter, and the second row is the derivative for the density function to second parameter. And then we have the G bar. G bar is the Jacobian. Jacobian is metric with the size two row and two column. Okay. And then you use while for the iterate, and then you take the parameter theta to parameter. Okay, this alpha x is mean the alpha or the first parameter for the theta 2 parameter. Theta x is mean the second parameter for the theta 2 parameter. And then we give the density function of two parameter Sujatha and the log likelihood two parameter for the Sujatha. Okay, the last one we have discussed here is this for the three parameter Sujatha. And then I think it's not important to us to give the lot of explanation to the three parameter because we have discussed about this one. Okay, we run our program for the first, for this one parameter, two parameter, and the third parameter. Okay, we run our program. Okay, we have success to run our program here. And then if you want to know the parameter for the theta, this is theta for the Sujatha 3 parameter, you copy here, you copy, and then you pass here, you pass. Okay, you can check this is the 4 theta parameter. Then it's lambda, copy this for the lambda, pass here, and then the lambda and the alpha, copy you take here. Okay, this for the alpha. This is the 3 parameter for the 3 parameter Sujatha distribution. Okay, if you want to know the parameter for the 2 parameter Sujatha distribution, you can come to the alpha x, copy, and then you pass here. Okay, this is so for the alpha and the theta x, you copy here, pass. Okay, this is for Sujatha 2 parameter. And then the parameter for the one parameter Sujatha, you can call theta SG1T. Okay, copy here and you put here, paste it, and you can enter. This is for the parameter of the theta for the one parameter Sujatha. Okay, after we have success to the estimated parameter, we try to make the good of fit test using the density plot. Okay, this is our density plot. Okay, we run our program. Okay, you can check here. Okay, when we try to analysis of this graph, the red one is representative for Sujatha one parameters. And the blue one is for the two parameters, and the green one for the representative of Sujatha three parameters. We can check here. Sujatha two parameters is very good in the capture the histogram. Okay. And then we can check here the red one or the Sujatha one parameters is the best one. So in this research article, we can take the conclusion Sujatha two parameters is the best model for the new case COVID-19 in the Indonesia. Okay, like I said before, for the everybody, maybe student, maybe the lecturer, or maybe the researchers need the program, we can open by slowly. You can see here, this is our data, and then this is this program for the Sujatha one parameter. Okay, you can check here very slowly. We are using art programming for the Newton reaction. Okay, this is our programming. And then this is log likelihood Sujatha one parameter and density function for the Sujatha one parameter. And then this one is Sujatha 2P. It means Sujatha two parameters. Okay, there is a long equation. We open it slowly. You can check here. Okay, we open it slowly. We hope this can help you to support your research when you research use this programming. Okay, we have checks. You can check here. Okay, this is for the Sujatha two parameters. Sujatha two parameters. This one, the theta two parameters. Alpha x and theta x. This is a log likelihood for the two parameters Sujatha and then density two parameters. And don't forget in the density we use xi. Xi is mean the sequence 0 until the two multiple maximum data with the step 0.1. You know that because we need a lot of point to make the smooth curve to the density function. Okay, in the shift parameter, we have discussed, I think this is not important again to discuss about the shift parameter because we have discussed here in the another time. Okay, from this, okay, we try to make the, okay, we forget for the density or the likelihood to Sujatha, we open slowly because there's long equation here. And then for the third, for the three parameter, okay, you can check this very long equation here. So I will open this slowly. You can check here. Okay. This is density and likelihood. Okay. So this is nice program I see. And then of course we try to check by AIC. AIC. We run IC one parameter, IC two parameter, and IC three parameter. You can check console. Okay, you can check here. We have discussed when we analyze the graph, the blue one, the representative, the two parameter Sujatha is the best one. And then if we try to use the good of fit test using the AKK information criterion, we can check the IC for the Sujatha two parameters is the smallest one. So it means the Sujatha two parameter is the best model for the new case COVID-19 in Indonesia. Okay. We have success to discuss about the how the comparison 1, 2, and 3 parameter Sujatha distribution with application in the new case COVID-19 in Indonesia. From this moment, we have shown to the audience in the international research class, we always support with the R programming to solve the problem in the one research article. So that's why Rado Institute choose the research article where the research article completes by the data. Because if we have the data in the research article, we can help the audience to make the well explanation of the research article, how to produce the graph, the parameter, and the all thing that we need, of course, by using the art programming. But you must remember, if there, if the result from the international research class and the research article so different, the Rado Institute cannot claim the research article makes something wrong. We cannot say that. Okay, I say that if there are different results between Rado Institute and the research article, the Rado Institute cannot say the research article there is some mistake. I cannot say that because it's a research. The researcher have the different methods for the doing research. So it means the audience can choose which one is the better. It's important. The Rado Institute never say the research article make the some mistake. Okay, I think this is time. This is good moment and a good discussion. And then we see you again in the next time. Rado Yendra with the Rado Institute. Thank you very much.